When we talk about water in the Canadian prairies, we often think of the rivers and reservoirs that supply water to our cities, or maybe we think about the wetlands that support important ecosystems and hydrologic cycles. Less often, though, we think of groundwater. Now, despite drawing less attention, groundwater is an important prairie system. It supplies approximately 30% of domestic water use. It sustains sensitive wetlands, maintains soil moisture, and regulates long-term hydrologic cycles. As an invisible resource, groundwater is difficult to study and characterize, especially at the scales relevant for developing groundwater management and protection strategies. Now, with this in mind, my research is focused on applying novel methods and widely available data sets to characterize and simulate the dynamic response of prairie groundwater systems. Now, one of the few methods that we have for directly observing groundwater systems are observation wells. These provide data that can be visualized in the form of a groundwater hydrograph, which represents changes in subsurface water storage over time. Now, these hydrographs are the result of the superposition of surf processes that occur in a variety of temporal and spatial scales. So to make sense of this collective data, I'm applying time series analysis and adapting quantitative indices to interpret groundwater hydrographs and identify characteristic patterns and trends that are associated with known physical processes. So these characteristic patterns can then be correlated with physioclimatic descriptors that represent things like climate, topography, and land use features. And this enriches our understanding of the controls over these dominant processes, and it ultimately leads to a better conceptual understanding of regional groundwater systems. Now, this work will form the foundation for the development of a functional aquifer classification and will ultimately support the development of models for simulating groundwater level response to climate variability. These quantitative indices, conceptual models, and analytical routines that I'm developing can hopefully be adapted for use by groundwater managers and practitioners to better identify the impact of climate variability and landscape alteration, and provide early indication of changes to aquifer water storage. Ultimately, it's my hope that this work will help make this invisible resource more visible and will draw attention to the importance of protecting groundwater systems through the sustainable management and protection of this important resource. Thank you.